Solve the following systems by the method of your choice. So we're gonna start by selecting one of the two methods that we know, that it's either addition or substitution. Definitely addition method you cannot use here because we need to have like terms aligned with like terms, and you see how these two equations, yeah, they both have x's, they both have y's, but one has an x squared, the other one has an x to the first, the other one has a y squared, the other one has a y to the first. So they're not, even though they're the same variable, they're not really like terms because they need to have the same exponent. So definitely we have to use substitution method. So always choose to solve for, in substitution, you have to have one of the two equations solve for a variable. You have to choose what's the easiest equation to use to solve for, and choose the to solve for whichever variable you think is the easiest out of both. So definitely the second equation is the one that looks like the simplest one to solve for a variable, and I'm going to choose to solve for y. It would be the same thing to solve for x, but I'm just choosing to solve for y just because. So we're gonna subtract x from both sides. We bring down the y. We equal negative x minus 13. So this value, you're gonna plug it in where? Into the y of the other equation that we have not used. So let's say this was our first step. From here, I'm going to do step 2. So step 2 is going to be using the other equation that I have not used, x squared plus y squared equals 85, and into the y of this equation, I'm going to substitute the value of y that I solved for right now in the previous equation. So x squared plus parenthesis, because the y is going to become multiple terms, negative x minus 13. And the y is raised to the second power, so whatever you substitute into the y has to also be raised to the second power. So then we start simplifying. You're going to have to do FOIL method. With this parenthesis, you're going to multiply that parenthesis by itself 2 times. So x squared plus, now with this multiplication you want to be careful because there's a lot of negatives. So I'm going to put a parenthesis here and start multiplying each of this. So negative x times negative x, positive x squared. Then negative x times a negative 13, it's going to be positive 13x. Then negative 13 times negative x, positive 13x. And negative 13 times negative 13, positive 169. Equals 85. So then let's simplify that parenthesis if you want first. As a matter of fact, since you're adding, you're doing x squared plus everything that's in this parenthesis, this plus is not going to affect anything that is inside. We can just bring everything down with the parenthesis that each term has, and we can just simply combine like terms. So x squared can be combined with x squared, negative 13x can be combined with negative 13x. So 1x squared plus 1x squared, 2x squared. 13x plus 13x is going to be 26x plus 169 equals 85. And then we're going to move this 85 to the other side. Let's have all our terms on one single side. Since most of them are on the left, let's take this 85 to the left side. So this is going to be 2x squared plus 26x plus 169 minus 85 is going to be positive 84. These two are going to cancel, so you have a 0. You end up with a 0 here. And now we have to solve for x. So 2, 26, and 84, they all have in common that they can be divided by 2. So the greatest common factor of all of them is 2. By using reverse multiplication or reverse distributive property, we're going to do 2 times what gives me x, 2x squared, well, 2 times x squared. 2 times what gives me 26x, 2 times 13x. 2 times what gives me 84, it's going to be 42 equals 0. And then next, we factor again this expression as a trinomial. So two things that multiply together give me x squared, x times x. Now I need to think of two numbers that multiply together would equal 42, but added would give me 13. So let me think. 42 divided by 3, 3 and 14, no. Divided by 4, nope. By 5, no. By 6, 6 plus 7, 13, yes. 6 times 7 is 42. I was doing it in my calculator. And added, it's 13. So 7 and 6. Plus and plus. So these three expressions or factors are multiplying times each other. So 2 equals 0. It's a false statement, so we're going to disregard that. There's no x to solve for, and that is just something we have to ignore, because technically you have to bring down every factor equal to 0, yes, but there's not a variable to solve for in there, and we're trying to solve for x. X equals negative 7, sorry. X plus 6 equals 0 minus 6. So this is x equals negative 6. So these are the two values of x that I got. Okay, so this was step 2, basically. The substitution of the y value into the y of the other equation gave me these two x's. Now what I need to do is, as a third step, it's going to be substitute this x's where into one of the original equations. Now, technically it shouldn't matter if you substitute. If these were linear equations both, it wouldn't matter if you choose the first one to substitute or the second one. But here, when it comes down to you solving a system of nonlinear equations that the second one is a line but the first one is not because of the exponents being higher than 1, that's going to be a circle, the equation of a circle, you have to always choose the easiest one. Always. When you see that one of the equations has higher exponent than 1 and the other one does not, you always want to choose the easiest one to substitute. It makes a difference. So we're going to substitute into x plus y equals negative 13. X plus y equals negative 13. So into the x, we're going to be substituting. So here, negative 7 plus y equals negative 13. So we're going to add 7 to both sides. So y is equals to 6. Over here, we're going to substitute negative 6 into the x. And then we're going to do plus 6 on both sides. So we're going to do negative 7. Y equals negative 7. So these are the corresponding y's to those two x's. So your solution it's going to be -7, 6, -6, -7. This is using the first x and y paired together and the second x and y also paired together. And you always put a comma in between the two solutions. Okay. So that is this. Okay. Now here it says graph the following systems of inequalities. Shade the region that represents the solution to the system or state that none exists. So this equation is the equation of a circle. I didn't do a space. Of a circle with center at 0, 0. And with radius, and you're going to do the square root of the 81, which is 9. Remember that this equation is written in x squared plus y squared equals the radius square form. So the radius is always going to be taking the square root of the number that is to the right side of the inequality, or the equal sign, in this case an inequality, right? So, and this other one is going to give you, it's going to be a linear equation. So let's do first the circle. The circle is going to have the center at the origin. The radius is 9, so you're going to count 9 units going up, 9 units down, 9 units to the right side, 9 units to the left side. So here, 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 and here. Then we're going to put a circle. Need to make it a little bit smaller. And I'm trying my best, but it's not gonna be completely perfect, right? But more or less right there. We can make it a little bit bigger there. Okay, so that's the circle passing through the points that we set, formed by the radius. So from the center to any side on this circle, the radius is 9 units. That's what the radius is, a measurement from the center of the circle to any side of the circle. Now, in class I was showing you with the calculator. This time I'm going to show you without it, because I think it's easy to do. So let's go by parts. We're going to find what's the region that we should shade for this circle. And you have two choices only. Either the solution for this circle graph is going to be shading inside for this inequality, or shading outside, the outer part of the circle. Either or. How are you going to figure that out? You're going to use what we call a test point. A test point. So you can choose a point inside of the circle, any point you want, or a point on the outer part. If you ever have the opportunity of choosing the point 0, 0, that's the best numbers you can use. That's easy to test. So what are you going to test them? Well, this point has an x and a y coordinate, so you're going to substitute them into the inequality that corresponds to the circle, which is the first one, and you are going to substitute them in the corresponding variables. In this case, x and y are the same value, right? So 0 squared plus another 0 squared. And you want to see if, when you simplify this, it gives you true inequality, if it satisfies the inequality. 0 squared is 0 plus 0 squared is 0. So 0 plus 0 is going to be 0. So you need to ask yourself, is 0 less than or equal to 0? It may not be less than, but it's equal. You have the option of this number on the left side being equal to the one on the right side. So therefore, it's satisfying the inequality, it's true. So the solution for this circle is going to be shading the inside of the circle. So I'm going to select this. Why it's not shading? Because why it's shading like this? Okay, I think I figured it out. Let me erase this. Okay, let's see. So let me shade it in pink. So the solution supposedly for this inequality circle is shading all the area inside. Okay. I'm sorry about shading that part. So there. Everything inside is shaded. Now, this problem has two inequalities, right? Not only one. So now I need to figure out what would be the solution for the other inequality. So for this one over here, I'm going to solve for y first if I want to graph it. Probably because I know that it's a line, the easiest thing that I can do is solve for y. So meaning leave the y by itself. So let's subtract negative 5x. This is going to be 2y less than or equal negative 5x plus 10. Then you're going to divide by 2. Y less than or equal to negative 5 halves x plus 5. So you have two choices. Once you solve for y, you can put it into your calculator if you want, into the y equals. You can put negative 5 divided by 2 x plus 5 and simply get a table of values from here, or you can plug in numbers to the x. Just think it's easier to get the values from here. Faster. So we can choose for a line maybe 2 points, 3 points, it's good enough, it's up to you. So I'm going to choose 0, 5 and 2, 0. Trying to avoid the decimals. So 0, 5 would be right here and 2, 0 would be right here. And we're going to draw a line. Okay, let's put it in green also. Okay, so this is the line passing through these 2 points. So now we need to find out what's the solution for the line. See, the line has two sides. The left side, the right side of the line and the left side of the line. So you have to again do a testing point. Choose a point either to the right side of the line or to the left side of the line. See, on the left side, the point 0, 0 is located on the left side of the line. And I told you that if you ever have the opportunity of testing the point 0, 0, I'm suggesting that that's the best thing you can do. So we're going to test 0, 0, but we're going to test it into the linear inequality, not into the one that gave us the circle. So we're going to test it into, I'm going to go back to the original, 5x plus 2y less than or equal to 10. Now, could you have substituted it into the one that I solved for y? Yes, but just to be on the safe side, and just to do the same thing every time, and you're not going to be double guessing and thinking, what do I do? Just go always to the originals when you're going to substitute the point. So 5 times 0 plus 2 times 0, it's going to be 0 plus 0, 0 less than or equal to 10. So ask yourself, is really the number 0 less than or equal to 10, and I think that's true. 0 is less than, it may not be equal to 10, but it's less than 10. So it's true. So where did we get the point 0, 0? From the left side of the line. So I'm going to shade in. Let me get probably this one. Let's see how it's going to look. So the solution for the line is shading all this. Okay. So we're going to be shading all this. Do you see where the two different colors meet? Okay. They're meeting right here, where I'm coloring in light blue. That's where the two of them are meeting. A piece of the circle divided by this line. So the area that I shaded in light green, that's the actual solution. Okay. So I'm going to put here region of solution. Okay. So you on your test you can shade really light the solution for one figure, for one function, and then shade really light the solution for the other function, and then make darker or make it noticeable that it's different, the final solution for both. And the final solution is where the two shading meets or where they overlap. That's the solution. Okay. So, or you can, like, if at the end you're saying, okay, I know this is the solution, and you wanna erase all the shadings and just leave the final one, that's also fine. Okay. So that's this one. For this one, solve the following systems of equations using Gaussian elimination with back substitution or Gauss-Jordan elimination. So I'm gonna use Gaussian elimination with back substitution. So for this one, let me make this a little bit smaller to have more room. Okay. I'm gonna start here. So we're gonna write down 1, the coefficients of all the variables 1. I'm leaving a lot of space. 1, 1. Then you draw the line. 7. The numbers that go after the equal sign go after the line. And then 1, -1. 2 and 7. The x value is 2. Be very careful. There's no y, so you put a 0, and then your z is 3, and then this is a 14. So our goal, just keep in mind what is it that you want to do when you are going to use Gaussian elimination with back substitution. You want the first column to look like this. Column 2, this number can be whatever number it is, as long as you have a 1 here forming this diagonal of 1s, and underneath the 1s you need to have zeros. Third column can be whichever number. This one can also be whichever number, and here you're going to have a 1. So these numbers to the left side of this line, I want them to look like this. That's my goal. So if you observe the first column, and you're going to work by columns until you finish doing the first column 1, 0, 0, then you can move on to the next column to start forming the 1 in the middle, then the 0 that is below it, and then when you move on to the third column, the first thing you're going to do is do this entry at the very end, a 1. So if you look at my matrix, into the first column, the first entry, it's already a 1, so that's done already. So the next thing that I'm going to do is make this 1 into a 0. So I'm going to think of a rule that modifies that number that it's in row 2. And so we can do, you see how over here on top of the one that I circle there is a value of 1 also. Well, I need, in order for this one to be a 0, the one that I circle, I need to add to this one the opposite of it, which is a -1, because 1 minus 1 would be the only way to convert this one into a 0. So we're going to do that by doing -1 times every number in row 1, and then we're going to be adding that to every number in row 2. So why am I saying that? Because if I do -1 times the one on top of the one that I circle, -1 times that one is -1, and then you add it to this one that I circle, and that's 0. So what I'm going to do is I'm going to write all the numbers in row 1, 1, 1. Let me do it here to the side. 1, 1, 1, and 7. And all these ones we're going to multiply them times a -1. -1 times every row 1 is represented here. So -1 times 1, -1. -1 times 1, -1. -1 times 1, -1. -1 times 7, -7. The rule says then to add every number that is in row 2. So 1, -1, 2, and 7. And then we're going to add them up. So all these numbers that I just wrote are the numbers in row 2. So this is going to be -1 plus 1, 0, -1 plus a -1, -2, -1 plus 2, 1, -7 plus 7, 0. These are the new values of row 2. So here in my next matrix, that's what I'm going to do. 1, 1, 1. The first row, nothing changed on it. But this second one is going to become 0, -2, 1, 0. The third one right now, we haven't done anything to it. It's going to stay the same way. Okay. So this one was this one that you see here, right? So now I need to think, okay, what's the next step? Well, I want to make below the 0 that I just did in the first column, that 2 I want to turn it into a 0 also. So now we want to change row 3. So how? We're going to change row 3 by adding to this 2 a -2, right? So -2 times the one that you see on the top, which is in row 1, plus every number in row 3. So let's copy all the numbers in row 1. 1, 1, 1, and 7. And we're going to multiply all these ones times -2. So -2 times 1, -2. -2 times 1, -2. -2 times 1, it's a -2. And then -2 times 7, -14. You're right. I feel like I put all this, like if I didn't have space or something. 1, 1, 1, 7. So we multiplied all this by -2. So this was -2, -2, -2, and then this was -14. And so now we're going to add every value in row 3. So 2, so you copy all the numbers in row 3. I'm going to put a line here so that you don't get confused with the things that I already did, because they're looking too close together. So -2 plus 2, it's 0. -2 plus 0 is -2. -2 plus 3 is 1. And -14 plus 14 is 0. So then I'm going to draw a line here for my next step. And so here, I'm just going to copy all the numbers in row 1. 0, -2, 1, 0, and then these values are going to be here in row 3. 0, -2, 1, and 0. So now what do we want to do next? Well, now I finished my first column. I want to make this one into a 1. So row 2, we're going to multiply it by the reciprocal of -2, which the reciprocal, it doesn't mean changing the sign. You're going to leave the sign the same. But you're going to multiply the reciprocal of 2, which is 1/2. So -1/2 times every number in row 2. So I'm going to put here every number in row 2. And we're going to multiply them, each of this, by -1/2. So -1/2 times 0 is 0. -1/2 times -2, that's going to be a +1. Can use the calculator for that one, if you wish. -1/2 times 1 is -1/2. And -1/2 times 0 is going to be 0. So now, these are the values that you're going to put in place of row 2. 1, 1, 1, 7. And so these ones are going to go here in row 2. 0, 1, -1/2, 0. So this is going to be 0, -2, 1, and 0. So what's the next thing to do? We want to make this -2 into a 0. So row 3, we're going to figure out a way to make it a 0, and that's by adding a +2 to this -2. So you're going to do it by -2 times every number in row 2 plus every number in row 3. Now, why -2 times the one in row 2 and not times the one in row 1? Because you don't want to change these zeros. And if you use the first row, you're going to make them change because of this one, the first one that you see in the first row. So you have to use row 2, the one that has the 0. So row 2, it's 0, 1, -1/2, 0, and you're going to multiply this one times -2. So -2 times 0 is 0, -2 times 1 is -2, -2 times -1/2 is going to be a +1, and then -2 times 0 is going to be 0. And then to this one, you're going to be adding every number in row 3. So 0, -2, 1, and 0. So this is 0, this is going to be -4, 2, and 0. So 1, 1, 1, and 7 are still the same. Row 2 is still the same. And move this one to the side so that we can have a better space. And then here comes the third row. So it's going to be this one going here. 0, -4, 2, and 0. I just realized I did a careless mistake. We wanted to make this -2 a 0. So I needed to add to this -2 the opposite of it, which is a +2. And I don't know why, because I guess I was looking at the -2. I put a negative here. So -2 times this one, it's a -2. When you add -2 plus another -2 is -4, not a 0. So then this -2 should have been a +2 here also. So 2 times 0, it's okay, 0. 2 times 1 should be just 2. 2 times -1/2 should be a -1. And 2 times 0, it's okay. So here, these two our answers are going to be different. These ones are the same. But 2 plus a negative 2 is 0. Negative 1 plus 1 is 0. So here, these two are not right. 0 and 0. Sorry about that. So, and I'm going to repeat to you what I did before I move on. I needed to add a positive 2 here. And by mistake, I put a negative on this 2 that I was going to multiply times this 1. So when I did negative 2 times 1, I got negative 2. When I added this negative 2 to this other negative 2, I got a negative 4, not a 0, which was the purpose of the whole thing, making it into a 0. So for me to do that, I needed to do 2 times 1 is 2. 2 plus a negative 2 is 0, just like you see here. So this is a special case. We should stop here trying to make 1s and 0s and so forth. We're not going to make this next column, this 0 into a 1, because look at the last row. The last row has all zeros everywhere. Every entry in the last row is all zeros. When you have this, when this happens, you have a special case as far as the answers. You're going to have the case of infinitely many solutions. But the problem doesn't stop at saying, yeah, the answer is infinitely many solutions. You have to write the answers with equations. So you have to form an equation with this too. X plus y plus z equals 7. You know this represents the x column, the y column, the z column, and this line is your equal sign, and then your constants over here to the side. Then the second equation is going to be no x, 1y minus 1/2 z equals 0. Okay. So we need to write the answer in the form x, comma, y, comma, z, right? But we don't have a unique solution, so we're going to write the x, the y, and the z as equations. So the first thing you're going to do is start with the smaller equation. You're going to solve the smaller equation. The question is, for which variable are you going to solve it? If you look at z and z, it's the only variable that is common in these two equations, or that it's repeated in both. So you're going to solve the smaller equation for the variable that is not the one that is in common in the two equations. So you're going to solve for y. We're going to move this negative 1/2 to this side. So you're going to end up with y is equals to 1/2 z. 0 plus 1/2 z, 1/2 z. So those two cancel out. So this is going to be the answer for y. But now, to find the other equation, the x equals equation, an equation that we're going to solve for x, you're going to substitute this value of y into the y of the first equation. So now we're going to get the first equation and into this one. We're going to substitute 1/2 z into the y, because we are seeing here that y is equals to this. So x plus 1/2 z, this all the entire 1/2 z is your y now, plus z equals 7. When you substitute 1/2 z into y, what you have is two like terms, two terms with z. So you're going to add them up, you're going to combine them. 1/2 plus 1, imagine here there's a 1 at the front. So you can use a calculator for adding 1/2 and 1 whole, but that's going to be 3/2. Equals to 7. So we're going to solve for the variable that was not the one that was commonly repeated in the two equations that we created at the beginning. So not for z. You're not going to solve for z, you're going to solve for x. So we're going to move this term to the other side. How? By subtracting it. Minus 3 half z. Oops, put an equal sign. Minus 3 half z. Whatever you do on one side, we do on the other side of the equation. So you end up with x equals 7 minus 3 half z. You're not going to be able to combine these two. They're not like terms. So all I'm going to do is write the term that has the variable first and then the constant at the end. Negative 3 over 2z plus 7. And that's your equation solved for x. So remember, the solution has to look like this, right? X, y, z. What's the value for x? This equation that you see here. I'm going to put here negative 3 half z plus 7. That's your x value, comma, your y, which is 1 half z, this one over here. And then at the end, you're just going to put the z, which is the equation, the variable that we never solved for, that was this one, repeated here in both. And this is your answer in terms of x, y, and z. So all this here was your x, all this here is your y, and all this z is just down. Next problem. Oh, and I forgot to say that this kind of answer means that we have infinitely many solutions. But on the test, it's not enough to say that it's infinitely many solutions. You have to do the entire work. After realizing that you have the last row being zeros, you have to do everything that I did here, forming equations to write the answer. For this next one, solve the following matrix equations for x. You have this equation. The first thing you want to do is solve this equation for x. So leave the x by itself. Send the b to the other side by subtracting. So you have negative x equals 3a minus b. And then you divide every single term by negative 1 to cancel this negative at the front of the x. So x is equals to 3 divided by 1, negative 3a, negative b divided by negative 1, positive b. So into this equation, we're going to substitute. So I'm going to go here to this side. Negative 3 times a plus b. Negative 3 times what's a? It's going to be your matrix. 3, 0, 7, your matrix A. 5, 1, negative 9. Plus B. Plus matrix B. 6, negative 3, 0, negative 6, 5, and 6. So you're going to multiply every value in matrix A times a negative 3 first. So you're going to get negative 3 times 3, negative 9, negative 3 times 0, negative 3 times 0 is 0, negative 3 times 7, negative 21, negative 3 times 5 it's negative 15, negative 3 times 1 it's negative 3, negative 3 times negative 9, positive 27, plus matrix B. So first you do the multiplication, then after you did the multiplication of 3 times every value in matrix A, then you add this 2. So negative 9 plus 6, it's going to be negative 3. Negative 15 plus negative 6, negative 21. 0 plus negative 3, negative 3. Negative 3 plus 5 is positive 2. Negative 21 plus 0, negative 21. And 27 plus 6. So this is going to be your final answer. Okay. So moving on to the next problem. And this one says, for the following problem, find the product A times B if possible. So you have product means multiplication. You're going to multiply A times B, and you have to set them up in the order that they're telling you to do the multiplication. So A times B means you're going to put first A and then B. So negative 1, 1, 3, 4, times B, which is 0, negative 2, 5, 1, negative 3, and 2. So in multiplication, you're supposed to do always row times column. You have to remember that. So I'm going to multiply the first row, negative 1 and 3, times the first column and the second one, 0, 1. Negative 1 times 0, it's going to be, well, and I forgot to tell you something since the very beginning. We should always check what's the order of each of the matrices. So the first one, it's 2 rows by 2 columns. 2 rows horizontally by 2 columns vertically. This other one has 2 rows, 1, 2, by 1, 2, 3 columns. So if the numbers in the middle are the same, if the number of columns in the first one is the same as the number of rows in the second one, then that means that the product, the multiplication, is possible. So these two must always match, let's say. They must be the same. The rows in the first one and the columns in the second one, they're going to tell you how your answer is supposed to look like. So ours is supposed to look like we have 2 rows by 3 columns. So like this. So 2 rows horizontally, 1, 2, 3 columns. So multiplying row times column, we're going to do this times this. Negative 1 times 0, 0, plus 3 times 1 is 3. You're going to multiply the first entry in the first row times the first entry in the first column. Second entry in the first row times second entry in the first column. Now, same row with the next column. Negative 1 times negative 2, positive 2. 3 times negative 3, it's a negative 9. And you're always adding the multiplications. Then the same row times the next column. Negative 1 times 5, negative 5. 3 times 2, 6. And now we're going to move on to row 2, and then times each of these 3 columns, times row 1 first. So negative 1 times 0, 0, 4 times 1, 4. You have the answers. Then second row times second row times second column. 1 times negative 2 plus 4 times negative 3, negative 12. Then second row times third column. 1 times 5, 8, 5, plus 4 times 2, 8. So A times B is going to look like 3, 0 plus 3, 3, 0 plus 4, 4. 2 plus negative 9, negative 7. Negative 2 plus negative 12, negative 14. Negative 5 plus 6, 1. 5 plus 8, 13. And that's your product, A times B. Okay, moving on to the next problem. We have to find the inverse of the following matrix, if possible. There's two ways to find the inverse. One is using a formula, and one is just something very similar to what you do when you're solving a system of linear equations using matrices, which is putting your diagonal of ones, your zeros underneath the ones, and so forth. Both would give you the same answer, so I'm going to do both. And then you choose whichever method you want. The formula one you can only use when your matrix is a 2 by 2. That is that size. If your matrix is bigger than that, then you cannot use the formula. You have to use the other method. So if you're going to use the formula, here is the formula. Where are these variables coming from? From your original given matrix, which is usually set up in, obviously it has numbers, but it's in this form, A, B, C, D. So when it says here 1 over A times B minus B times C, they're saying 1 over 5 times negative 2 minus 0 times negative 3 times this determinant, where basically what you're doing is switching from place the A and the D value and changing the sign, or multiplying times negative 1 the value of B and C, or changing their signs to the opposite, however you want to see it. So using this method, it's going to be 1 over A times D, so 5 times negative 2 minus B, which is 0, times negative 3, times D, which is negative 2, A, which is 5. So basically I just put this two, I switched them. Negative 2 went in place of A, 5 went in place of D. And then B, I have to multiply times negative 1, so 0 times negative 1 is still 0. And then C, which is a negative 3, multiplied times a negative 1, it's a positive 3. And you just work it out. So this is going to be 1 over 5 times negative 2, it's a negative 10, minus 0 times negative 3, which is 0. A inverse 1 over negative 10 minus 0, negative 10. So basically your entire fraction is negative 1 over 10. Because anyway, positive over a negative is going to give you a negative. And then you're going to multiply that by each of the values. So A inverse, negative 1 over 10 times negative 2, it's going to be a positive 2 over 10, but if you reduce that, that's going to be positive 1 over 5. You can do the multiplications in your calculator if you need to. Negative 1 over 10 times 0 is 0. Negative 1 over 10 times 3, negative 3 over 10. And negative 1 over 10 times 5 is going to be negative 5 over 10, which can be reduced to negative 1 over 2. So this is one way of getting the inverse of a matrix when the size is 2 rows by 2 columns. Another alternative you have is the following, and the following method you can use when the matrix gets bigger. When it's a 3 by 3 and you have to find the inverse, you can use the other method, and you should get the same answer. So in the other method, if you're going to find the inverse of A, you're going to copy the original matrix, 5, 0, -3, -2. Oops. And you're going to draw a line here. And you're going to put an identity matrix of a 2 by 2. An identity matrix is the one where you have your diagonal of 1 and zeros everywhere else. And this time, you know how when we were solving systems of linear equations by matrices, we were just doing the diagonal of 1s and making the numbers below the ones 0. I wasn't making this 0 on the top. But this time, if you're going to use this method, you have to do the zeros on the top. So you have to work making the 1s, making the zeros, not only the 1s. So you have to be doing the same thing as we were doing, row operations, to make this 5 into a 1 first. So you want the numbers in blue to look at the end like the ones in green. And where the numbers in green are, that's where your answer is going to appear. So to make that number, that 5 into a 1, that is located in row 1, we're going to multiply 1/5, the reciprocal of 5, times every number located in row 1. So we're going to write 5, all the numbers in row 1, 5, 0, even the numbers after the line, multiply times 1/5. So 1/5 times 5, it's 1. 1/5 times 0 is 0. 1/5 times 1, it's 1/5. And 1/5 times 0 is 0. These are going to be your new values in row 1. 1, 0, 1/5, and 0. So you have -3, -2, 0, and 1. Next thing we want to do is this -3, we wanted to make it into a 0. So row 2, it's going to be affected by multiplying 3 times every number in row 1, and then we're going to add it to every number in row 2. So row 1, it's 1, 0, 1/5, and 0. And all these ones, we're going to multiply them times 3. So 3 times 1 is 3, 3 times 0 is 0, 3 times 1/5 is 3/5, 3 times 0 is 0. Then we're going to be adding every number in row 2 to each of this. -3, -2, 0, and 1. So 0, -2, 3/5 plus 0 is 3/5, the same thing. 0 plus 1, 1. So A inverse, it's now 1, 0, 1/5, 0, and then over here on the bottom, on the second row, 0, -2, 3/5, and 1. If you see on the next row, we already have the number on the top being a 0. So now we just have to make this -2 into a 1. We have to convert it into a 1. So we can multiply by the reciprocal of -2, which is -1/2. So -1/2 times every number in row 2. 0, -2, 3/5, and 1 times -1/2. So -1/2 times 0 is 0. -1/2 times -2 is 1. -1/2 times 3/5, it's going to be -3/10. -1/2 times 1, -1/2. So then finally you have 1, 0, 1/5, 0, 0, 1, -3/10, and -1/10. Over 10, no, over 1/2. Over half. Over 2. If you look at this side, this is what your inverse is of matrix A. And these numbers should be the same numbers as the ones that I got in the first method. So if you check 1/5, 0, -3/10, -1/2, if you compare it to this one, it's the exact same thing. 1/5, 0, -3/10, -1/2. So then you choose your method. Again, I'm going to repeat. You can choose either method when to find the inverse of a matrix when your matrix is 2 by 2. Once the matrix gets bigger, maybe the formula exactly the way that it's here, it's not going to work. You're going to have to do it like this way. So just be careful with that and realizing that if it gets bigger, you cannot use the formula. You're going to have to use this method. The last problem, evaluate the following determinants, simplify the answer as much as possible. Okay, so evaluate the following determinants, simplify the answer as much as possible. So we're gonna, this is what I always tell you, to put a plus on the first column, a minus in the second column, a plus on the third column. This is gonna tell you the signs that you need to be putting once you start solving the smaller matrices. So we're going to start by covering the first row, the first column, I'm sorry, and the first row. Column it's the one that is vertical, and the row is the one that is horizontal. So in order for me to do that and not be having to erase and take away what we did and you don't see it anymore, we're gonna I'm gonna copy this matrix 3 times. And I'm gonna be showing you here with each of this what we're doing. So the first time we're gonna cover the first column with the first row. So what's covered twice? Twice the 0. Here you can also do what I was telling you about the signs. So you're covering the 0 twice, so you're going to start 0. You copy the number that is covered twice, always. And this 0, you have to multiply, like whatever number this is, you have to multiply times a positive sign, which doesn't change anything. Basically, whatever this first number is when you cover the first column and first row, you're just going to copy it straight over here the way that it is. Because multiplying a number times a positive sign doesn't affect anything at all. So 0 times, and you see how there's 4 numbers left that have not been covered. So you're going to do the determinant with this too. You're going to multiply diagonally in this direction first. X squared times -4, -4x squared. Then you're going to subtract, always you're going to subtract the multiplication of the other diagonal. 8 times 9 or 9 times 8, which is going to be 72. So once you do that, then you move on to the next matrix, which is going to be, now you're going to cover the second column with the same row. The row is never going to change. The columns are the ones that you're going to be covering differently every time. The first one, then the second one, and then the last one we're going to cover the third one. So what's the sign that we see at the top of this column? A minus, and that's what you're going to put here, minus. That's what the signs are for. That's why I told you to put in there. So you're covering twice an x. That x is going to multiply times the multiplication of the 4 values that are left there. Start always multiplying this way. X times -4, -4x, minus 8 times x, 8x. Okay. Then you're going to move on to covering the same row with the last column. So what sign you have on the top of that column? A plus. What's being covered twice? The x. X times, and you're going to multiply diagonally this side first. X times 9, 9x, minus, you're always subtracting x squared times x minus the multiplication of the other side, which is going to be x to the third. So now you're going to start simplifying. Distributing, multiplying, or whatever you can do inside of the parentheses you're going to do first. For example, inside of this parenthesis, I cannot combine anything. 4x squared minus 72, they're not like terms. Besides the fact that these two cannot be combined, 0 multiplied times each of these two terms is going to be 0. 0 times each of them is going to be 0. So basically we can just kill all this entire multiplication. So 0 times anything is going to be 0. Then you're going to be doing negative x here. And you know what? I just saw that this 2 can be simplified. So I'm going to bring down negative x. Oops. And then we can combine these two in the middle. Negative 4x minus 8x, negative 12x, plus over here 9x minus x to the third, they cannot be combined. They're not like terms, so you can distribute the x, the positive x, times this 2. X times 9x squared, it's times 9x squared, I told you the answer. X times 9x, 9x squared. X times negative x to the third, negative x to the fourth. You add the exponents. And then over here, in the next step, we can multiply these two terms. X times negative x times negative 12x, positive 12x squared, plus 9x squared minus x to the fourth. So you have two terms that you can combine together because they're like terms. They have the same variable with the same exponent. So 12x squared plus 9x squared is going to be 21x squared minus x to the fourth. And that's it. The only thing you can do is probably rewrite it from greatest exponent to smallest. But even that would be okay. If you don't do it on the test, I mean, it's fine. If you don't put them in order, from greatest exponent to smallest, it's okay. And so this particular determinant is not going to have a numerical value as the answer. It's just an expression. There's nothing else. You're going to stop at the point that there's nothing else to multiply or distribute or combine like terms. Like, there's nothing else you can do. That's it.